Hey folks, why is the obtuse angle so upset? Because he's never right. Alright, welcome to video lesson 6-3, our lesson on vectors. Alrighty, some vector vocabulary for you. A vector is a directed line segment. It's used to give a value that has both a magnitude and a direction. Okay, vectors are named with lowercase letters. So a vector is going to have both a length, its magnitude. The symbol for magnitude looks like this. We're going to put a number inside there. It's double absolute value bars. Okay, and the vector's magnitude can be found using the distance formula. And a vector's direction, it's the direction that it's going, the direction that it's pushing, it can be used finding slope. The initial point of a vector is point P. That's where the vector begins. And the ending point, the terminal point of the vector, is called Q. So this vector here, has an initial point at P and a terminal point at Q. And we typically name vectors with lowercase letters. So this could be vector U. Okay, so a vector in standard position. A vector in standard position is a vector whose initial point is at the origin. So that's how we're going to be actually working with most vectors. So the component form of a vector is written with an ordered pair. The terminal point of the vector is going to be an ordered pair whose initial point is at 0, 0 at the origin. And we always write a vector in component form using not parentheses, but hard brackets. Hard brackets. So go ahead, folks, right now, see if you can figure out what this vector, who starts at -2, -3, and ends at 4, 3, what would that vector look like in standard position? Well, we're going to move the vector so it looks like it's right here. And what would the terminal point be of that vector? Go ahead and give it a go. Okay, this vector's ending point, the terminal point, is going to be at 6, 6. So it looks like right here, this point right here is 6, 6. And if that did not come to you intuitively, there's a formula that you can use. The formula is we're going to subtract the x's first. So this is going to be 4, the terminal point, minus -2, the initial point of my x's. And then we're going to do my y's, which was 3, the terminal point of the y. And then subtract the initial point of the y's, which is -3. So now we can see we have an ordered pair in hard brackets 6, 6. Component form of a vector. Okay, what is the component form of this vector? Notice that this vector is in standard position. Its initial point is at 0, 0, and its terminal point is at 5, 2. So in component form, this vector is going to look like this. Hard bracket, 5, 2. Okay, if I want to double the length of this vector, just double the length, so make the magnitude twice as big. So I'm going to make my vector now twice as long. All I'm going to do is I'm going to do scalar multiplication. I'm going to multiply this vector by 2. So I'm going to put a 2 out. Hey, go away. I'm going to put a 2 outside. So this new vector is going to be 10, 4. Notice the hard brackets. So that vector, 5, 2, multiplied by 2 would be 10, 4. And that's this point right there. So if I look at these two vectors, I got vector u in component form. It's right here. The initial point is at 0, 0. The terminal point is at 2, 6. I got vector v, which is at -8, 3. So the initial point, again, is at 0, 0. These vectors are both in standard position. We would consider this a first quadrant vector. This would be a second quadrant vector, right? So this vector right here, its terminal point is at -8, 3. If I wanted to add these two vectors, to do that algebraically, quite simply, I'm just going to add my x's. So let me get my marker, do it in green. I'm going to add my x's. I'm going to get negative 6. I'm going to add my y's, which is going to be 9, negative 6 comma 9. So the resultant vector, the vector that's the answer of vector addition, is the resultant vector. The resultant vector would be negative 6 comma 9. Okay, to do that graphically, what I'm going to do is I'm going to take vector v, which is right here in green, right? And we're going to move vector v, so we're going to put the initial point of vector v on the terminal point of vector u, and we're going to draw that. Just move that vector right there. So there's vector u, so vector u is right here, plus vector v. My resultant vector, I'll do that in red. Let me get my marker back. Whoop. My resultant vector is going to go from 0, 0 to my new terminal point, and there's the resultant vector at negative 6 comma 9, hard brackets. Remember, a vector in component form is with hard brackets. Hey, rocket science here, folks. Rocket science. To do vector subtraction, we're going to do the exact same thing, but this time we're going to subtract the coordinates. Okay, so to do it algebraic, and notice I messed up when I typed these in. I put that vector v was 4 comma 1, but vector v is actually 1 comma 4. So make sure you fix that in the packet if necessary. But we're going to subtract these two vectors, and I'll do that in a different color than red. We'll do it in green. Okay, so vector u minus vector v is going to be negative 4 minus 1, which is negative 5, comma 7 minus 4, which is 3. Notice that these are in hard brackets. That's in component form, a vector in standard position. The terminal point, written in hard brackets, is the component form of the vector. To do this algebraically now, I'm going to do the exact same thing again. So I'll do it in green. We'll take vector v, which is right here. But this time we're not going to add it to vector u. And vector u is a second quadrant vector. We're going to subtract it, so we're going to go the other way, right down to here like that. So we're going to do, that's a picture of vector u minus vector v. I need to go one more space, actually, right to there. So now you're going to note that my resultant vector, and I'll do that in a different color. We'll do it in red. It's going to be right here, negative 5, comma 3. Boom. Okay, so for this guy right here, we're going to find the component form and the magnitude of vector v. So vector v, its initial point is at 2, comma 2. That's going to be right here. Its terminal point is at negative 1, comma 4. So to move this vector to standard position, I'm going to move it. So here's my vector v. Whoop, I need a marker. So here's my vector. What can I put my... There it is. Bump. And I'm going to move that guy right down to here. So it's going to look something like this. Right? And so to do that, remember now, we're going to subtract the x's. So this is going to be 2 minus 1, which is... or negative 1 minus 2. I'm sorry, we do q minus p. So it's negative 1 minus 2, which is negative 3. Comma 4 minus 2, which is 2. There's my vector, negative 3 comma 2. Okay, and then what we're going to also do is we're going to find the magnitude. So I'm going to do basically in component form. It's real easy. I'm going to do the square root of my x's squared plus the square root of my plus my y squared. So this is going to be the square root of 9 plus 4. So this has a magnitude of root 13. Okay, more vocabulary. A lot of vocabulary. A unit vector is a vector with a magnitude of 1. So a unit vector is a little tiny vector that has a length of 1. So it's just a little tiny unit vector. It's a vector whose length is 1. The formula for a unit vector is you take the vector in component form and divide it by its magnitude. So go ahead right now, folks, go ahead and find the magnitude of this first quadrant vector, vector v. If this is vector v, its terminal point is at 8, 4. It's a first quadrant vector because its terminal point is in the first quadrant. Go ahead and find that magnitude. Okay, you should have found that the magnitude of the vector was 4 root 5 because we're going to do 8 squared plus 4 squared. The square root of 8 squared plus 4 squared is the square root of 80, which of course becomes, when I simplify that, 4 root 5. So I'm going to take my original vector, which is root, in hard brackets, 8, 4, and I'm going to divide both of those by 4 root 5. So it looks like my vector is going to be 2 over root 5, comma 1 over root 5, which of course if I rationalize is going to be 2 root 5. Whoop, I need my hard bracket. 2 root 5 divided by 5, comma root 5 divided by 5. Both of those are decimals less than 1. My little unit vector in the direction of v is this little guy right here in blue. It's a little tiny vector with a length of 1, and that would be inside that first grid. Okay, more vocabulary. Standard unit vectors are unit vectors, so they are vectors with a length of 1. That are our standard unit vectors are the vectors that are both the horizontal and the vertical unit vectors. So their standard unit vector is going to be I. The horizontal unit vector is I. It's 1, 0. So a standard unit vector I looks like this. Whoop. With a length of 1. And this standard unit vector that's vertical is j, right there. Okay, so vector j would look like this. We'll go up 1. So another way to write a vector. If this vector 7, negative 3, it's a fourth quadrant vector, right? It's a fourth quadrant vector. It's right here. Another way to write this vector, that right now this is in component form, is using standard unit vectors. It's a linear combination of I and j. So do we agree that vector 7, negative 3 is going to have 7 i's? So 1, 2, 3, 4, 5, 6, 7. 7 i's minus 3 j's. 1, 2, 3. Whoop. So the resultant vector of 7i minus 3j is going to be that vector 7, neg 3. So we can also write this vector as 7i minus 3j, and that's just another way to write a vector. You can write it in component form, hard brackets, or you can write it as a combination of standard unit vectors I and j. So 7i minus 3j. Okay, so let's look at this one right here. Find a unit vector in the direction of the given vector. Verify that the result has a magnitude of 1. Okay, so first of all, we're going to look at vector v right here. It is certainly a fourth quadrant vector. This terminal point is at 3, negative 4. So I can actually write that if I want. This is at 3, negative 4, right? But the whole point is now we're looking for a little guy. We're looking just for a little unit vector in the same direction that has a length of 1. Okay? So what we're going to do right now, first of all, what would this vector be in a linear combination of i's and j's? What would this vector be as a linear combination of i's and j's? Very good. That's going to be 3i minus 4j. Okay, but again, that has nothing to do with this problem. But any which way, so we're going to take this vector and we're going to find the magnitude of this vector. What is the magnitude of vector v? Well, it's going to be the square root of 3 squared plus the negative 4 squared, which is, of course, 9 plus 16. This is a 3, 4, 5, so this has a magnitude. So the magnitude of v, notice the symbol for magnitude is 5. So I'm going to take this vector right here, vector v, and divide both the x and y coordinates by 5. So the unit vector of v, is going to equal 3/5, comma, negative 4/5. Okay, and I should have put that in hard brackets. There's our unit vector for a unit vector that has the direction of vector v. It's 3/5, comma, negative 4/5. I could verify that the result has a magnitude of 1 by finding the magnitude of my resultant unit vector, which is going to be 9/25 plus 16/25. 9/25 plus 16/25 is 25. 25, which of course is 1. The square root of 1 is 1. Okay, we're moving on here, folks. There's a third way to write vectors. So far we know that vectors can be written in component form. So this vector, whose initial point is at 0, 0, and whose ending point is at negative 4, comma 4, this is a second quadrant vector. It's a second quadrant vector. Okay, if I were to write this in component form, I'm going to write this in, I'm going to get my marker, I'll do it in blue. In component form, this would be hard brackets of the ordered pair of my terminal point, negative 4, comma 4. That's one way to write this vector. I can also write this vector in red as a linear combination, a combination of our standard unit vectors, which are our i's and j's. So this would be negative 4i plus 4j. And the third way to write a vector is called the directional angle form, which is going to be the magnitude. And remember, this is the symbol for magnitude right here. The symbol for magnitude, so it's the magnitude of the vector times cosine of the directional angle I plus sine of the directional angle j. And we're going to find the directional angle of a vector using arctan. So let me show you what I mean by that. So we're going to find this angle right here. It's a second quadrant vector. So actually you should be able to do this without using arctan. You should just know that this angle right here is 135 degrees. Okay? But if not, we can always find that directional angle. So we know that tan of theta is going to equal the y, which is 4 over negative 4. And we just need to know to put that angle in this second quadrant. So we could arctan negative 1, and of course then move that to the second quadrant. We would have 135. So the third way to write this angle is, first of all, let's find the magnitude. What is the magnitude of this green line right here? What is the length of that line? I'm hoping, again, without using the Pythagorean theorem, you can figure out that it's 4 root 2, because it's a 45, 45, 90 right triangle. So we have 4 root 2, that's the magnitude of my vector, times the directional angle is 135, so this is going to be cosine 135 degrees I plus sine 135 degrees j. So in red now, let me get my pointer, in blue, component form of this vector is negative 4, comma 4. Linear combinations of the standard unit vectors is negative 4i plus 4j. And the directional angle form of this vector is going to be the magnitude, 4 root 2, times cosine the directional angle, 135i, plus sine, 135j. All right, rocket science, a little bit of rocket science. In exercises 73 through 78, find the magnitude and the direction angle of the vector v. So this vector v, okay, this is going to be a second quadrant vector. In fact, it's very similar to the one we just did. This is in magnitude times directional angle form, so my magnitude right here, my magnitude is 8. So I'm going to write that. Bump. Let me get a maca. So the magnitude of vector v is equal to 8. And the directional angle of vector v is going to be 135 degrees. So that vector, if I wanted to draw that vector, would look something like this, where this is a magnitude of 8, and it has a directional angle of 135 degrees. Boom! Okay, this guy right here, folks, we are almost done. Almost done. Find the magnitude and the direction angle of the vector v. Well, here's vector v right here. Vector v. Okay, this vector v, its terminal point. You guys tell me, what is its terminal point? Good, it's 12, comma, 15j, or 15, that's the terminal point. So if I wanted to write this in component form, of course it would look like this, hard bracket 12, comma, 15. Okay, this right here, v equals 12i plus 15j, is the vector in linear combinations of standard unit vectors form. I just call that the ij form, okay? So this is going to be 12i plus 15j going up. So we can actually, I'm going to label that in. I'm going to draw that in a little bit right here. I'll do it in red. Whoop. So this is 12i. And this is 15j. Okay? So if I want to find, first of all, let's find the magnitude of this. We're just going to do the square root of, okay, using the Pythagorean theorem or the distance formula, 12 squared plus 15 squared. Of course, that's the square root of 144 plus 225. Whip out your calcs, folks. Whip out your calcs. My calc out too. I got the square root of 369 is approximately, I'll do it correctly here, approximately, a little squiggly equal sign, 19.2. Okay, the square root of 369. So that's my magnitude. And my directional angle now, my theta, I know that tan of theta, so here's my theta right here. Tan of theta is equal to 15 over 12. So I'm going to arctan both sides. So whip out my calc again. I got second tan of 15 divided by 12. I'm pressing buttons on my calc right now. Pressing the buttons. I got an angle approximately. Whoop, I need my maca. I got an angle approximately of 51.3 degrees. So if I were to write this in directional angle form, I'm going to have my magnitude, which is approximately 19.2, times cosine of 51.3i plus sine of 51.3j, close parenthesis. Boom. All right, boys and girls, I should give you all a bonus point just for making it this far. I won't, but I could, but I won't. So here's everything we've done. Okay, directed line segment, that's a vector. Initial point, the P, the terminal point, the Q. Magnitude is the length of the vector. That's the symbol for magnitude. Okay, component form of a vector, hard brackets. Hard brackets. That's these. Scalar multiplication, that's what we use to make vectors either longer or shorter. We're going to multiply by a scalar, which of course is just a number. Vector addition, we're going to add the x's, add the y's. You can use the parallelogram method to do it visually. The resultant vector, the answer vector, when I add or subtract vectors, is called the resultant vector. A unit vector is a vector with a length of 1. Standard unit vectors are the i's. The horizontal standard unit vector is I. The standard vertical vector is j, the standard unit vector. So i's and j's are my standard unit vectors. Linear combinations are another way to write vectors in ij form, and of course we just did directional angles form, so the magnitude times cosine theta I plus sine theta j. If you have any questions about any of this stuff, make sure you come into class mañana, and we shall go over it then. Hey folks, that's it. This is a longie but a goodie. Have a great day, and I shall see you soon.